Okay, so here we go. We're talking about absolute values today. This is our last day of inequalities. You're going to have a short assignment, a short lesson. If you get an inequality, absolute value, and you see a less than sign, we think less than. And means that it's a conjunction, so your graph should do something like this. If you see an absolute value is greater than something, you would think great or than. And if it's an or, it's a disjunction and it will go apart. Funny thing about absolute values and inequalities is that sometimes there are, I guess, more delicate solutions. For example, some people will look at the next situation and they would say less than, and they would set up two inequalities, and they would become confused afterwards. Let's think about it. Absolute value will always be what? Positive. So if you see an absolute value is greater than a negative, is that ever not true? It's always true. So therefore, your solution set will be all real numbers. You come up with any type of absolute value. Absolute value of 1 minus 2x is greater than negative 4. I promise you, any number you plug in for x is going to work. I promise. Does that make sense? The absolute value will be positive. A positive will be greater than a negative. Can an absolute value be less than a negative? Never. No solution. So if you have a positive number on the right-hand side of an inequality from an absolute value, you know that you're probably going to be okay to set up 2. But if you have a negative number or if you have 0, you got to be careful. For example, can an absolute value be less than 0? No. So next one is similar. It can't be less than, but could it be equal to? So that's just one solution wherever absolute value of x is equal to 0. One solution. Can an absolute value be greater than 0? Is it always greater than 0? Except for where it's equal to 0. So in this case, it would exclude one number. There would be one number, some number x, that would be excluded from the solution set, and it would look like that. Is there any situation where an absolute value wouldn't be greater than or equal to 0? So all real numbers will work in that situation. So in order to try to understand, the first thing you need to do is you need just an absolute value. So I'm going to add 9, so 2x minus 3 is greater than 30. So now that we have that, we need to identify the right-hand side, the 30. Is it 0 or a negative number? No. So we could just do it like you would normally do and realize it's great or, so will it be a conjunction or a disjunction? Be a disjunction, we set it up by saying 2x minus 3 is greater than 30. And then the second one will be 2x minus 3 is less than negative 30. So we add the 3, 2x greater than 33, divide by 2, x is greater than 16.5. The other side, add 3, 2x is less than negative 27, divide by 2, x is less than negative 13.5. It says to graph and represent the solution in interval notation. So you can see from our work that we should have a disjunction. X is less than negative 13.5 and x is greater than 16.5. And sure enough, our graph matches accordingly. our solution set, negative infinity to negative 13.5, union with 16.5 to infinity. What up, dog? Just talking about you. All right. All right, you do the next one on your own. Go. Darren, you never. All right, Darren's gonna bring them on Friday. Cool. You can check your answer. This is what you should have, right? When you divide by a negative, remember to switch the sign. Questions on that example? Once, twice, thrice. Okay, look at C. C, I should divide both sides by 6, and I get the absolute value of x minus 5 is less than or equal to 0. Blue boy, I got a 0. I better worry about it. Can an absolute value be less than 0? What could it be equal to? There's just one solution here. Wherever x minus 5 is equal to 0. These simple you guys think about it. So that would be at x is equal to 5. That's the only number that will work. D, what do I do to both sides? We get the absolute value of 2x minus 3 is greater than negative 13. Oh, I got a negative. So better think about it. The absolute value be greater than negative. But not greater than negative. Therefore, all real numbers. Short lesson, short assignment, lots of work time. Thank you, Mr. Gaines. 1.7, page 87, 57 through 66. Enjoy the short lesson. Get to work. We got a long day tomorrow.